Morning. We're continuing with 5.2 today. Remember, chapter 5 is about trigonometry, and we were dealing with right triangle trigonometry. We built sine, cosine, secant, cosecant, tangent, and cotangent, 6 main trig functions on right triangle so far. We will first finish 5.2 today, and we will start investigating those 6 trig functions on circles today. Okay? Alright, quick review again. We learned some basic values of trig functions like sine. What is sine at 60? What is sine at 45? What is tangent at 30? And we built a table of values, and I requested you must for sure know the first 2 columns. The other 4 can be obtained from these first 2 columns by using the trig identities relations, like tangent is sine over cosine, secant is 1 over cosine, cotangent is cosine over sine, etc. And I believe the last thing we did was this table. This actually summarizes the relations between 6 trig functions. Sine is related to cosecant, tangent, cotangent is related to each other, and also sine and cosine. Okay, and we also learned this. It's called Pythagorean identities, because it's just like leg squares equals hypotenuse square. The most important one is sine squared plus cosine squared is 1. The other 2 can be obtained from this by dividing both sides, sine squared and cosine squared respectively. We finished this, I believe, number 7. We were about to start cofunction identities, I believe. Okay. Alright, here we go. Alright. There is a relation, not direct relation, but kinda not equality, but there is an indirect relation between sine, cosine, tangent, cotangent, secant, cosecant values. If you are wondering what sine 30 is, for example, and you can't figure it out, you forgot or you hesitate, if you know cosine 60, then there you go, you found it. How? If you don't want to deal with sine, you probably know cosine values better. All you need to do is subtract that value from 90. In other words, sine 30 is equal to 90 minus 30, which is 60. So you can get sine value through cosine. Opposite is also true. Oh, I'm good at sine values, but I don't know cosine values. And if you want to compute, for example, cosine 45, all you need to do is subtract 45 from 90 and instead compute sine value. Okay? We can convert this relation into radians. If you are wondering what sine pi over 6 is, pi over 6 is 30, remember? All you need to do is subtract pi over 6 from pi over 2 and compute pi over 3 instead. And because when you subtract pi over 6 from pi over 2, 90 minus 30 is 60, you already know, but by setting common denominators, that's 2 pi over 6 or pi over 3. How did I get that? I multiplied both sides by 3. 3 pi, take away 1 pi, it's 2 pi. Divide by the common denominator 6, that's pi over 3. Same thing through between tangent and cotangent. Oh, I don't want to compute 30. Then instead compute 60. Cotangent 60 then. 90 minus the angle is the trick. Same true for secant, cosecant. Oh, I don't want to compute secant 45. Or no, this is radians. I don't want to compute secant pi over 4. Then subtract pi over 4 from pi over 2. That's actually another pi over 4. And compute cosecant pi over 4 if you wish. Okay? Does it make sense? What is it called again? Cofunction. Okay? Cooperate. Co means together, so they go together, sine and cosine. Alright, can you guys compute pi over 6 alternatively? We know already is root 3. But I'm just wondering if you can go another way and compute it. If you don't want to compute cotangent pi over 6, then what is your alternative? Ashley? Look. Always take its pair. What is the co-function of cotangent? Tangent. And then take pi over 6 off of what? What do we subtract it from? It's always 90 or pi over 2. Okay? So we compute instead this. And I know that these needs to meet at 6 common denominator. So we have tangent 3 pi, take away pi over 6. And that's tangent 2 pi over 6. Canceling 2 and 6 into 3. Tangent pi over 3 is, now I assume you know tangent pi over 3, which is, we already know it's root 3. But again, in case you hesitate, oh, I don't know tangent values, then convert this into sine over cosine. And instead these values, do these values. And sine pi over 3, at least you need to know these now, is root 3 over 2. Cosine pi over 3 is 1 over 2. They cancel and become root 3. Got it? Okay. What is cosine pi over 6? Let's see who remembers this. Anyone? I'm just testing your table values. You haven't memorized them yet? Cosine pi over 6 is root 3 over 2. Okay? How about sine pi over 3 then? Yep. How do I know they are meeting? Because this is 30, this is 60. They are complementing each other to 90, right? So cosine 30 is the same as sine 60. 90 minus 30, remember? Okay. Alright, we're done with basic trig relations. We're going to apply it into a real life question here. There is a lamppost here. So there is a lamp here. Okay. Now, when sunlight hits this, it has a shadow. So this is the shadow of it. Shadow. So sun hits this like that, okay? And it makes a shadow here. And they have already given that the angle of elevation of the sun, in other words, the sunlight hit this lamppost at this degree. In other words, this elevation is 30.80 degrees. The elevation of angle of sunlight is 30.8, means it makes this angle with the ground when it hits. Alright, you are trying to figure out x. What we are given is shadow length 14. You're given 14, you're given an angle. We don't know the hypotenuse, but they are asking for x. What can we do here?
Use tangent to find it.
Okay. Why did you pick tangent?
Because you're trying to find the opposite and you have the adjacent.
Mm-hmm.
And you have an angle.
Right. We have an angle, that means this is given. We have an adjacent side given. and opposite side asked. So this is the best option. What other trig function could you use here other than tangent? What other trig function uses opposite, adjacent, and the angle? Cotangent. You could have go with cotangent. It will just flip adjacent and opposite that time. But this is better because we like what is asked on the top. So this is a better choice. If the shadow was unknown and the height was given, I would go with cotangent because I like unknown on the top. Alright, let's put everything back in place, but we definitely need a calculator because I don't have this value on the table. I don't know, tangent 30.8. It's almost 30 with some change. Okay? What was tangent 30? We figured it out. No, this is 60 we found. Tangent 30 is root 3 over 3. But this is a little bit more than root 3 over 3. So you need to get a decimal value here. We needed nearest foot, so get a couple of decimal values. Opposite value is unknown x, adjacent is 14. And to get x by itself, I want to multiply both sides by 14. So this can cancel. X is going to be, the height is going to be 14 times tangent 30.8, whatever this value is. So let's get this computer. Tangent, I'm not sure if I can do degrees here though. No, I don't think Google can do degrees.
Isn't it just automatically degrees?
I think the default value for Google is radian, but I know how to change this into radian. So if you don't like a degree value like 30.8, I want to change it to radian, and maybe your default setup for your calculators is again radian. If you don't want to change to degree, what do I need to do? How do I change degree to radian? Perfect. And then I multiply this by 14 as well, right? Let's see if we can do this. There we go. We have it. 8.34. They want the nearest foot, so it's 8. Agree? So this is about, x is about 8. Did you get the same thing with your calculator? Go. Alright, number 10, and our last question here. Pretty much the same setup. This time the scenario is different. There is a building here, a wall of the building. This is wall. Alright, and you are putting a ladder here. Can you imagine a ladder here? Ladder is just leaning against this wall. So it's kind of height, of course, it's longer. This wall is longer, but we just cut it off here. Okay, and there is a window you're trying to reach somewhere on this wall. There is a window. I don't know how low or how high. There is the window. You're trying to make it. Window. And that window is given 17 feet above from the ground. So this height is, although the wall is longer, the window is right here, standing here, and you want to reach to this window with this ladder, and that window is 17 feet above. So we know one leg of the triangle. We also know the angle of the ladder with the ground, which is 61. What else do we know? I need to know 3 things. In a triangle, to solve for something, I need 3 things. I have 2 so far. What am I missing? Right. The ladder is 20 feet ladder. So this hypotenuse given, leg is given. They're asking for, what is it asking? Oh, they're asking whether I'm going to make this window or maybe I'm going to fall short. Maybe I'm going to make it only here. Okay? Window is up here maybe, and ladder is here maybe, okay? So how can I test this? So I want to figure out how far can I go up on this wall. So this is still, although its window is at 17, this side is mystery for me. I want to see how high can I go on this wall. So it's not 17 yet. Window is at 17, but ladder, the amount ladder is going up is X. So we need to figure out that X with 61 and 20. This is still 20, this side, 20 feet. This is still 61 angle. Alright? See if this X is lower than, no, higher than 17 or not. If you're higher than 17, the answer is yes. Alright, which trig function are we gonna use?
Sine.
It should be something related to opposite hypotenuse and angle. It is sine. I'm gonna call this theta. Sine theta is opposite over hypotenuse, and 61 degree given. To make your life harder, they didn't make it 60 but 61. Okay, opposite is still unknown. We want to see how high it goes up, and hypotenuse is 20. So this time x is 20 times sine 61. So I will just flip couple things here. I think we'll make this sine. $61 multiplied by 20. Wow, barely. Yes, 1749. We are reaching that window. So it's kinda, your ladder can go a little bit higher than the window level. Okay, 1749, round to one decimal place, that means 17.5, right? 49, it becomes 50. If they ask, I don't know, is it yes, no, type yes, and it's about, what was it, 17.5. Alright, what did I do wrong? Oh, my question is different. Okay, this is 65. Is this still the same ladder, those 20 feet? It's 17 feet. Alright, that's a little bit risky now. Let's see. This goes 15.4. Where is it? Oh, this is 7. No, where is that? 18? 14.9. 15.4. So we are good again. 15.4, yes, but 15.4. Now we got it. Alright, any questions? We are starting 5.3. Now remember, on Wednesday I warned you that only triangle method, finding sine, cosine, tangent, cotangent on triangles, can measure those trig function up to 90 degrees only. Because in a triangle, this theta cannot be more than 90. For example, can it be 100? No, 100 plus 90 is already 190. And in a triangle, the addition of three angles, interior angles, can never go beyond 180. The maximum is 180, so you can never have a sine, cosine of any angle more than 90. So we need an alternative. We need to expand our knowledge to cover all angles. I want to find out what is sine 255, okay? I want to find out sine 270 or 300. Okay? So what do? First off, we put this triangle onto positive x and y axis on we call it quadrant 1. This is first quadrant. Things in first quadrant are exactly the same. Look, your triangle is here. How do you compute sine and cosine? Sine is opposite over hypotenuse, right? Sine theta is opposite over hypotenuse. Opposite is y. Hypotenuse is r. R is the distance between this dot and origin. You measure it and record it and put it into denominator. That's your hypotenuse. Cosine, what is cosine theta? What is cosine? It is x over r. And you can get everything else, pretty much everything else, by this triangle. It's just flat, and the base of this triangle is on x-axis. Look, the leg is on the x-axis. Tangent is y over x. Cosecant, because it's opposite over adjacent. Cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent this time, and cotangent is adjacent over opposite, x over y. So you can get everything fine here. The question is, when this point is not in the first quadrant, guys, it's on second quadrant here. Then you connect them again. Alright. How do you measure sine of this angle all the way here up to there? Theta is now a wide angle, like 120, 130 something. How do you measure its sine? Because there is no triangle this time. Look, your triangle is look like this. It's not a right triangle now, right? How do you compute that? Same idea. Just imagine how you were computing in the first quadrant. What was the formula? Y over r. That's what you're gonna do. You are going to determine the coordinates of this point. It's going to be given to you like -3 and 5. Your sine will be, what was sine? So you need to memorize this. Y over r. So you will take this 5 and divide by whatever this distance is. Measure it, like 5, 10, whatever it is. You are going to measure it with a ruler or formula and then divide it. That's sine. How do I find cosine? I will take this number, divide by this distance. Okay? So forget triangles now. Whenever I give you a point, like this time I'm giving you something down here, and here's the point. I will give you those two values, x and y, and when I ask you what is sine, you will tell me y over r. You will compute this and divide y by it. No more triangles, got it? Y over r. X over r. What is tangent? Y over x. What is cotangent? X over y. You are using coordinates rather than side of the triangle's hypotenuse, adjacent side. Forget it. But yeah, in the first quadrant is still right angle formulas. Because x is this side, y is that side, r is hypotenuse, etc., etc. Is it clear? So first thing I request from you guys is forget adjacent and opposite side formulation for sine and memorize these. What is y? What second coordinate of the point? Distance to origin. First coordinate, distance. Second coordinate over first coordinate. distance over second coordinate, distance over first coordinate over second coordinate. We are working with coordinates, forget sides now. Okay? Alright. Another second important, first you learn now new sine cosine definitions. This is so important. Please, every time we need to compute sine cosine values of a wide angle, you need to keep this table in mind. What does this mean? In the first coordinate, when you are dealing with right triangles, in the first coordinate you have all right triangles, right? And you literally have a right triangle here. X and Y means sides, and they are always positive. These numbers are positive. Why is it positive? Because X and Y gets positive values in the first quadrant. In the first quadrant, when you compute those X and Y's and divide by distances, all you get is positive, 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 positive. First quadrant, sine, cosine, tangent, cotangent, secant, cosine. Wait a minute. Don't we have 6 trig functions here? I only see 3. Where are the others? Sine is the same as cosecant sine. What? Sorry. Sine is the same as cosecant theta in terms of sine, plus or minus. Why? Because cosecant is 1 over sine, isn't it? So if sine is a positive number, cosecant will be positive as well. So they kind of cut off the other 3 because cosine is pretty much the same as secant, and tangent is pretty much the same as cotangent because cotangent is x over y. If this guy is positive, cotangent is positive as well. So when you are taking this table, always think, oh, we also have cosecant here. We also have secant here. We also have cotangent here. So there are 3 functions, more invisible 3 more functions. In total, we have 6 trig functions tables here. Now, what is the story in the second one? Sine, cosine, tangent may change signs on the other coordinates. In the first quadrant, it's the easiest because it's all positive, all 6 are positive. On the second quadrant, sine is still positive, cosine is negative, tangent is negative. Why? Why these two turned into negative? Because cosine is computed by x coordinate of the point, and in the second coordinate, if you have a point, its x coordinate is always negative, right? That's why we have cosine values negative here. Tangent. Why is tangent negative? Because y value is in the second coordinate positive, x coordinate is negative, positive over negative is negative. I actually don't know this table. I always, whenever I have a question, I always imagine that quadrant. Here is the quadrant. I imagine its x coordinate and y coordinate. Oh, both are negative. If I'm using tangent, since both are negative, it's going to be positive. I always compute this in my mind in 2 seconds. Okay? You don't have to memorize this table. It's hard to memorize. I mean, you memorize now, you forget next week. So always think through points. There is a point here. Its x coordinate is negative. Y is positive. So sine will be negative because it's the y coordinate. Cosine will be positive because it's the x coordinate. Tangent is negative because it's combination of both negative and positive, and it's negative. Okay? Make sense? Alright, here is a test. What is the sine of cotangent 210? Just I need the sign. I don't need the result. Tell me plus or minus. Cotangent 210. What quadrant is it on? It's in quadrant 3 because this is more than 180. 180 is half circle. You're past a little half. So you're in quadrant 3. In quadrant 3, we have cotangent positive because it's both negatives. Yes. Look. Tangent is the same as cotangent here. Cotangent is x over y. X is negative, y is negative, the result is positive. Again, this is in quadrant 3. In quadrant 3, x is negative, y is negative, and their ratio is positive. Sine 310. Negative. Because this is in quadrant 4. It's past 270. 270 is where quadrant 4 starts to 360. This is in quadrant 4. And in quadrant 4, sine is y over r, y value, and y is negative. The distance is always positive, so it's negative. Okay? Alright. We are going to do this pretty much same work with this point. So why don't we first sketch this? Please read question, see what is asked. I want to, before anything else, I want to show where this point is. Negative 5. Negative 2, negative 4. Negative 5 is about here. Negative 6 is about here. And they meet each other there. This is your point. Okay? Now, we are going to compute its sine, cosine. So here is the angle. Here is the angle theta all the way here. Theta starts and rotate this much. This is the point. Sine theta, cosine theta, tan, cotan, secant, cosecant. 6 trig functions. But before anything else, I want to guess their signs. Can you tell me what sign will be sine?
Negative.
Negative. Yes. I'm expecting a negative answer here. How about cosine? Just look, cosine means x coordinate, it's negative. Tangent means their ratio, negative and negative. Cotangent is, again, their ratio, positive. Secant is the same as cosine, negative. Cosecant is the same as sine, negative. Once you know the first 3, you know the other 3. Okay, let's compute. Sine is y over r. Y is minus 6, but I don't know r. What is this distance? I'm lost. I need to compute r. I don't know what this r is. It's not given. Did I forget it? How do I compute that r? Pythagorean theorem, yes. There is a secret right triangle here. Do you see that? You can form it here, or you can form here as well. This is your triangle as well. It doesn't matter. But do we know this side? Yeah, it's 6. Do we know that side? Yeah, it's 5. You just square, add, and that's going to be r squared. So r squared is leg, another leg, square them, add. 36 plus 25 is 61. We take square root of both sides. It's root 61. Well, we need to rationalize this. Remember last time? And it says here as well. Whenever you see square root in the denominator, you multiply both sides by that. And there is no cancellations, unfortunately. Okay? So we already have sine. negative. Okay. I will get one more. Why don't we do sec? We already, yeah, why don't we do secant? Secant is, what is the formula for secant? It's 1 over cosine, but in terms of r, x, and y, it's r over x. Just if you know, cosine flip it. Isn't cosine x over r? So when you flip it, r over x is secant. What is r? Root 61. X is negative 5. So negative root 61 over 5 is the answer. Okay? I think you can do the rest, right? Okay. Going to the next one. Alright. There are 3 angles given here, A, B, and C. Oh, how nice they are. 270, 180, and C is 90. We need to put them in under sine, cosine, secant, and cosecant, and compute this ratio. Okay? So I need to get each and every one of these angles, like starting with sine A. What is sine A? If it helps, literally sketch that angle and figure out that way. So this is 0. Here is 90. So I start with 0. This is 0 angle, right? So let's rotate. 90, 180. Where is 270? There we go. Right? Okay. Now all you need is on this terminal point. Again, we start with this. This is your angle 270. You need any point on this terminal side, like 3, 5. They provided me -5, -6, so I can make my calculations. Now this is not provided to you. You figure this on your own. You're lucky because it's exactly terminated on negative y-axis. All you need to do is guess any value you wish. It's your choice. What number you want to pick here? Pick some number on negative y-axis. What's that? You don't know? Negative, I need 2 coordinates. 0, negative 10, for example. Can I choose negative 10? Yeah. Negative 100? Yeah. But what is the best choice? As Kylie said, go with the smallest amount you can go, -1. Okay? Alright? So, sine 270 is now y over r. What is the y value you went with? Right? -1. Okay, what is the r value? R is the distance from this point to origin. What is it? What is this distance? 1. It's positive 1 because distance is measured in positive terms. The answer is -1. Alright, what happens if you choose -100 here? You will have -100 divided by 100, same result. So your sine value is independent from the point. As long as you're on the terminal side, you go further and further, you divide more and more. It's the same ratio anyways. Okay? So I got this part done. I need to get cosine B next. Cosine of 180. cosine of 180 is x over r. I need to take this back to 180. This is too much. Here is 180. This is your angle now. I mark any value here. Again, what is the best option? -1, 0. And then r is 1. X is -1. Result is -1. Again, it's twice -1. Okay. Secant of 180, and I want to cheat. I know cosine 180, right? How do I get secant of 180? Aren't cosine and secant related? You flip these. In other words, 1 goes to the top, -1 goes to the bottom, it's still -1. This is -1. Cosecant C, I need to make this cosecant C. Again, this time my angle is a right angle. There you go. Mark a value on it. So I will mark 101 here. This is 90 degree. And cosecant is r over y. R is 1, y is 1, that's 1. And in total this is what you have: -1, -2, -1, -5. Why? Because 5 times 1 is 5. 2 times -1 is -2. There are numbers in front. And this is 1/3. Okay? No, 1/2. -3 over -6. That's 1/2, yes. Any questions? Are we good? But it's not a bad idea to remember these numbers we got. What is cosine 180? -1. Cosine sine 270 is -1. Okay, that kind of basic angles. Useful to remember. Alright, what's coming next is something called reference angle. These reference angles are going to be used to compute sine, cosine, tangent, cotangent of wide angles. Like I want to compute sine 210. How can I do it efficiently without plotting a point, finding its r distance, y value? How can I do it without that? For example, I know sine 30. Can I use sine 30 to compute sine 210? Yes, if you know what reference angle means. Okay? So reference angle is the shortest distance or angle that makes your terminal side with x-axis. So you measure the smallest angle your terminal side makes with the x-axis. Okay. For any angle that is terminating in the first quadrant, quadrant 1, it's the angle itself. Like they want, so you have 45 degrees, its reference angle is 45. 70 degrees is 70. So it's easy if your angle is in the quadrant 1, reference angle is equal to each other. And it's denoted by theta prime, and the theta is original. Reference 1 is equal to original if it's in quadrant 1. If it's in quadrant 2, like a wide angle like this, reference angle is this little angle, because your x-axis here, this is x-axis, the short side, a small angle to make x-axis is this side. So reference angle is this gap, and you need to find it by subtracting the original from 180. Such as if you have 150 here, I compute reference angle by subtracting it from 180, which is 30. So just think it like this. There is a fire exit door on x-axis. Either on the right, on the left, you can go grab these doors, open it, and you're safe. When the alarm goes off, fire alarm, which side would you run? Would you run to this side or that side? You always go with the short side, correct? You would go rotate more here and you hit this door because it's closest. So you pick the closer door on the left or right by picking an angle. For example, fire alarm goes here and you would go for this door rather than this one because you have to travel all the way here long. So if you have a third quadrant 3 angle, then you actually subtract 180 from the original and compute it. Like 210, this is 180, you subtract and compute 30. If you are in quarter 4, you subtract your angle from 360. This is like 360, this is like you have 300, and the difference is 60. Okay, so I don't memorize these. I visualize the door. Okay, I need to go run here. Oh, that's 360 angle. So I need to subtract 300 to measure this gap. Always go with visual aspect. I mean, some people memorize, oh, in quadrant 4, 360 minus theta or 270 something. No, we always run to 360 or 180. So you either subtract from 180 or 360, or your angle subtracts and 180. Okay? Alright, we'll do some practice on this one. Here's your angle. You need to first visualize where it is. Then do subtractions. Negative 120. Where is negative 120? By the way, negative angles means you rotate your initial side. Which direction? Clockwise. So I start this one and rotate it clockwise. How far is this? 120? This is 90, so I need to go a little past that, about 30 more. 90 plus 30 is 120. This is where it is. Okay, which side would you run? Would you go back and grab this door, or do you go forward and grab this one? Which side is closer? Left or right? Left. So how much do you need to go left to grab this door? 60. Oh, by the way, important. Reference angle is always positive. Don't tell me, oh, we are going backwards, so it has to be negative. No. We always measure it in positive terms. I need to go 60 more to make that exit. So it's 60. Oh, maybe I'm wrong.
You have to put the degree.
Oh yeah, it's always in radians as well. Pi over 3. Right? 60 is, how do you do that? Pi over 180, you divide by 180, multiply by pi. So it says radians obviously here, so it's pi over.
It says if the angle is given in degrees, give it.
Oh, maybe it's the other.
You just forgot the degree.
I forgot the degree, so I was good. That's another thing we need to pay attention. So it's 60. Yeah, when I put 60, it understands as radian. Yeah, it's not computer's fault. If you don't put nothing around it, it's radians. Okay, 240. Where's 240 now? Again, we back this up. This is start. Rotate 240. This is 90. 180. How much more is 240? 60. It's the same location as the last one. But this time you rotated it clockwise direction. Now counterclockwise direction. 240. So which side would you go? Forward, backward, back, left, or right? Exit. Of course, left. It's the same. 60. Ah, I forgot again. I'm glad we have more attempts. Alright. Wow, negative 1035? This is gonna take some turns. Negative 1035. Alright, negative means you are turning. Since 1035 more than 360, it's gonna make a full turn. This is negative 365. One turn is negative 265. Second turn is, no, not 365, 360. Second turn is 720. Okay, let's add up. So one turn is 360 degrees. Two turns is 720. Are we gonna make the third one? Add one more. 1080, right? Three turns is 1080. Did we do too much? Yes, we did. If you do 3 turns, it's 1080, so we need to back up a little bit. Again, negative. One, 2, 3 is 1080. Let me mark it. 1, 2. This is negative 1080. I need to go back up into negative 10. What was it? 35. So how much do I need to go back? How much?
45.
45. 80 minus 35. 45. So I'm going 45. Oh, 45 is halfway through. Halfway between x and y. And let's clean this back up. It's not this much. We stop here. This is negative 1035. So I need to go a little bit more and grab this door, right? Which is, we already know how much we bent back, right? It's 45 degrees. $4.95. Positive, so we are going counterclockwise. $4.95. This is 360. This is 90 more. 360, 90, 450. To make 95, I need to go a little bit more. Again, let me mark my moves. This is 360, right? 90 more, 450. This is 450 so far. How much do I need to go more? 45 more is gonna make it right between these two. 495 now. Okay? So that was 495 degrees. So how much are we short to make to the other side? 35. 45. Because this was 45. Okay. Alright, it's easy with degrees, but it's gonna be a little bit challenging with radians. But there is a cheating method if you wish to make. I don't advertise for it, but like 2 pi over 3. How would you find the gap? Measure the gap. First, how would you visualize where 2 pi over 3 is? So some of you guys are more comfortable with degrees, so you can kind of cheat and turn this in the background in your mind into degrees. How many degrees is this? Yep, just substitute pi by 180, divide by 360, double it 120. Oh, I know now where 120 is, right? It's a little bit past 90. So this is again what you have here and there. Now you can guess what this gap is, which is 60. So the reference angle is 60, but you're not allowed to enter 60 here. Turn this into radian, which is, how do you do that? It's multiply pi over 80, pi over 3, right? So you don't have to worry about that sign on this one, it's already radian. Second, I will do one more and we are good. Negative 5 pi over 6. Negative 5 pi over 6 means we are going into counterclockwise direction. This is at 0. Negative pi is this. Look, negative pi is half turn. So this is negative 5 pi over 6 is a little bit short, I believe, but I need to make sure. So tell me what is minus 5 pi over 6. If pi is 180, it is 3 times 5, negative 150, right? Negative 150 is this guy. Right? Am I right? Okay, how much distance is left to make x-axis left side? This is 30 degrees, but they want in radians it's pi over 6. Alright, why don't we do one more? 13 pi over 4. Oh, you can do this. If you see a big number divided by a small number, why don't you make a division and see if you can get any whole pies out of this? 13 divided by 4 is how many 4s does it go in here? 3, 12, 1. So this is 3 pi, look, quotient is 3 pi, and then 1 pi over 4 left. It's 3 whole pies, you put pi next to it, and leftover is 1 over 4. Look, remainder over quotient is 1 over 4 here, but you add 1 to it. What is 3 pi? 3 pi is full turn, this is 1 turn, and then half turn, and this is a quarter turn, no, not a quarter, 1/8 turn. Pi over 4 is 45. So half of a quarter. This is a half of quarter turn. Do you get it? 1 turn, half of a quarter turn. This is actually a slick idea. So to make, I mean, if you don't want to do degree conversion, yeah, you can do 180 times 13, but you need a calculator and divide. This is an alternative. So again, I make two turns. No, 1 turn, half turn, and a quarter turn. Half of a quarter turn, sorry. So this is 1 turn, half turn, and quarter more. Makes 13 pi over 4. So what is this gap? You grab the left side door, right? What is that gap? It's gonna be as much as this one, right? Half of a quarter, which is pi over 4. Because you're already here at 2 pi and pi. 3 pi is you're already here. You went ahead and then you come back for the exit. Pi over 4 is the same distance. Alright. In case if you want to use this, you need to make a fraction first. Go make pi. Okay? Alright, this is enough. I think you got it, right? Any questions? Now, where do we use what we learned so far? What did we learn? We learned this table. We learned reference angles, right? And we also knew this table from last class and did a little bit of this class as well. 30, 45, 60 degrees of sine and cosine. I ask you to memorize this. And if it's better if you know this side as well. But not necessary. You can always get this side if you need to. What we are going to do here is we are going to compute cosine, sine, tangent, cotangent, all 6 trig functions of wide angles, not only 90. Because if it's up to 90, yeah, I can cheat from this table. If this was, for example, pi over 4, yeah, go ahead and pick cosine pi over 4. There you go, you're done. This is 5 pi over 6. And how much is 5 pi over 6 in degrees? 150. How do I do 150? 150, first visualize where it is. 150 is a little bit more than that. Somewhere here. Why did I put it on here? Because I want you to use this table. I need first to determine sine of, what kind of sine, plus or minus of cosine for such an angle. 5 pi over 6. What is the sine? It's right here. What is the sine? Negative. First thing you're going to do is put that negative sign before anything else. Check the sign. I'm actually doing second one first. Do step 2 first. Then we will repeat cosine. Instead of this angle, use ref angle. Reference angle. What is the reference angle of 5 pi over 6? 150. What is the reference angle? Pi over, this is 30, pi over 6. So this is, actually you can use 30 if you wish, but I want to stick to the given unit, okay? Cosine pi over 6. All you need to do is look up the table and find out cosine pi over 6 and attach a minus in front. Because this table is for quadrant 1 values and they are always positive. So you're fixing the sign by this table. So you always make use of these two tables. Sign is going with this and the values are going with this table. So what is cosine pi over 6? The answer is negative root 3 over 2. Okay? Negative alright. Next. Wow, what a mess. 25 pi over 6. You can use the idea I gave you earlier. If the top number is quite bigger than the bottom, that means you have a lot of turns you're making here. Divide them. Or you can directly take 180 and multiply by 25 and divide by 6 and then make turns by 360, 360, 360. Okay? Degree or radian, fine. But I want you to get used to this as well. Divide 25 by 6. How many 6s going in there? 4, 24, 1 left. So it is 1 over 6 pi, or pi over 6 more than 4 pi's. Again, 1 over 6 pi, leftover goes here, divisor goes there, the quotient goes here. 4 pi plus 1 over pi. Well, isn't 4 pi 2 turns? So you are making here 2 turns. I'm making 1 turn, 2 turns, and go 30 more. Pi over 6, 30 more, I'm stopping here. So this is your angle. What is the reference angle of this thing? Isn't it 30 pi over 6? So this thing is the same as secant pi over 6. Well, what is the sign? You need to give me sign first. What is the sign of anything in the first quadrant? It's the easiest. It's always positive. Secant pi over 6, is it in the list? Yes, it is. 2 root 3 over 2. No, 3. Got it? Makes sense? Alright. Oops. It's not 6, I believe it's 3. Alright, we are almost halfway through. We're gonna continue next time with more questions.